Last daily assignment for sapling. Close your Chromebook. Like I literally said it multiple times now. I made a big deal about it, and we're still having Chromebooks open. All right. So this is going to be your next to last sapling assignment, unless I decide to throw in an extra one at the end. But generally, we're going to do this one, and then we're going to take the quiz, and then next week we're going to start to study for the final exam. So this one is going to be a little bit tough. I don't know how difficult some of the problems are going to be. But know that it's going to require you to use scratch paper, to write stuff down, and to think about the steps that you can do. So what we're dealing with today is Hess's law. This deals with thermochemical calculations. So we're talking about heat. When I do a chemical equation or reaction, I'm going to lose or gain a certain amount of heat. What Hess's law deals with is when I try to do multiple chemical reactions. If I have multiple chemical reactions, how can I add or subtract those together and figure out exactly how much heat I'm gaining or losing? So let's go through this. I'm using my laser pointer here. At times, bond energies and standard enthalpies cannot be found in a reference table, or a table is unavailable. And we kind of saw that yesterday. I don't really have it pulled up, but you remember the long list that we had yesterday. We were looking at the long list with like every single chemical on it, and it had the heat number with it. You can imagine there's a lot of chemicals that weren't on that list. There's a lot of chemicals in the world. You can't fit all of them on one single list for some high school students. So what they're saying is there's always, if you do anything out of the ordinary, it's going to be hard for you to find that on a list to get that number. So how can we take the stuff that we do have on lists and create new, unique chemical equations with them and do a little bit of math to figure out the answer? Hess's law is how we're going to be able to do that. So Hess's law states that states that the sum of the enthalpy changes for each step of a reaction is equal to the overall change for the reaction. So what does sum mean? Add. So what Hess's law tells us is that if I add together all of the heat changes for each step of a reaction, that's going to be equal to the total heat change for the entire reaction. So basically, if I don't have the heat change for the entire reaction on a list, what I can do is break that up into little steps. 1 step, 2 step, maybe 3. I'll tell you, if you get 3 steps, it's pretty hard. If you get 4, it's really hard. 2, it's not that bad. We can do 2. I think most of the problems are going to be 2. But you're going to take each step, you're going to take that heat change, and you're going to add it together to end up getting the final equation and the final heat change. Now, the problem comes with I'm not just adding the heat itself, I'm also adding those chemical equations. And adding chemical equations together is where it gets a little bit tricky. So, some equations require manipulation to produce the desired overall reaction. And so there's one way we can manipulate it. Well, actually, there's 2 ways. Sorry, there's 2 ways we can manipulate it. And then at some point, you have to add them all together and get your new chemical equation. So they're going to give us some examples. We're not to the example yet. If a reaction is reversed, the sign of the enthalpy change must be reversed. And their example is going to be like this. If I have this reaction, iron plus oxygen goes to iron oxide, that's going to equal negative 1625. Is negative sorry, my brain. Yeah, exothermic or endothermic? It's exothermic because the heat is leaving, right? But what if I do this equation backwards? If forwards it's exothermic, backwards, what's it going to be? Endothermic. So that's what they're telling us. If I flip this equation from left to right, I put the right stuff on the left side and put the left stuff on the right side, I get the same equation just backwards, and I have the same amount of heat, but just I flip the sign, positive versus negative. You're going to need to do this a lot. So make sure you figure out if I need to flip something, I also change the sign from a positive to a negative or a negative to a positive. You'll have to do that quite often. This is the first manipulation you can do. So there's only, when they give you these formulas, there's only 2 things you can do to them before you start to add. You can either flip it from left to right and change the sign, or what you can do is multiply it and make it bigger or smaller. Well, you can't make it smaller, but you can multiply it and make it bigger. So if I need more, like let's say I need 8 irons instead of 4 of them, I just need to double everything in this equation, right? So I double the whole equation. What's that going to do to my number? Double the number. So whatever, if I flip the equation, I got to flip the sign. If I multiply the equation by a number, I have to multiply that number as well and make sure it gets bigger. And so that's what they do here. What do they need? They need to triple everything. So they have a regular equation. I guess it's the 1625 they're tripling. And then they're going to triple it. So they end up with 6 irons, 12, well, this is iron oxide, 12 irons and 9 oxygens. And they have to triple the amount as well. So those are the 2 things you can do. And I will actually write this on the board real quick because we're going to do a little bit of work on the board. So 1, let me draw the one like this. 1, I can flip the equation. Sorry. And the sign. Having trouble writing today. No, that's not what because. Plus the minus. 2, let's see, is I can multiply the equation. Multiply the equation and the sign. And, and the delta H. There you go. So multiply the equation and the delta H. Those are the only 2 things you can do. At that point, if you've lined everything up correctly, then you can add your equations together and add your numbers together and finally get your answer. I know this doesn't make sense now, so let's go through an example problem. Step 1, they're going to give you multiple equations and they're going to give you a goal equation. So they give you the steps and they give you the final equation that you're trying to create. Your job is to rearrange the equations you have, the little steps, and get them to basically create your new goal equation. The key here is some stuff is going to have to cancel out. And so getting the stuff that you don't want in your goal equation to cancel out is actually the hard part, and making sure you have the right numbers. We'll start small, and we'll work our way up to bigger problems. Step 2, once I rearrange everything and get each of the chemicals on the same side of the reaction as the goal equation, step 2 is to multiply by any coefficients I need to make sure I have the right amount of chemicals. So step 1, get everything on the right side. Step 2, on the correct side, not right versus left, right, but right as in right versus wrong. Get everything on the correct side. Step 2, multiply and make sure you have the right amount of everything on the correct side. Then step 3, add all your enthalpy changes together to get your final answer. So here's your example. They tell me, calculate the enthalpy change when 2 moles of liquid hydrogen peroxide decompose into 2 moles of liquid water and 1 mole of oxygen gas according to the following chemical equation. So here's my chemical equation. This is my goal equation. This is what I want to create. Here are my other 2 equations that they give me, and they give me numbers for. So I need to take these and turn them into this. And so now, instead of doing it on sapling, I'm going to show you how we do it on the board so you can kind of get an idea how this is going. And this is why you will need scratch paper. Some of the problems will be easy and you might just be able to wing it, but you're probably going to need scratch paper to write it down. So here is my equation. I have my goal equation is what? 2H2O2. H2O2 goes to H2O and O2. So 2H2O plus O2. So this is my goal equation. And now I have 2 steps that they give me. So they give me the next 2 equations, which are my steps. I need to somehow take these and turn them into this. And so this is where, basically, this is a math assignment. This is like a straight up pre-cal kind of assignment. It's a little bit difficult, but if you think about it, we can get it. So what I have is equation 1, which is H2 plus O2 goes to H2O2. So H2 plus O2 goes to H2O2. And then my equation number 2 is what? 2H plus O2, 2H, which is, H2. Plus O2 goes to 2H2O. Okay, so first thing I want to see, on my equation 1, are my chemicals on the right side? Well, first off, my oxygen's on the wrong side. My goal equation up here doesn't have hydrogen, so I don't really need to worry about hydrogen. But what it does have, it has oxygen, which is on the other side. Here I'm on the left side, here I'm on the right side. And it has H2O2, right? Here I'm on the right side, here I'm on the left side. So what do you think I need to do with equation 1?
Flip it.
I need to flip it. And when I flip it, what do I do with the number? You change the sign, right? So these are also my two numbers, negative 188 and negative 572. So what I do is I got to flip it, right? So I'm actually going to physically flip this. And it's going to be H2O2 goes to...
O2 plus H2 plus O2.
Yeah. How many H2s though? One H2? All right, one H2 plus one O2. Okay, and when I flipped it, what I do? I change the sign. So now I'm positive 188, right? Now, what's the only other thing I need to do? I need 2 of these, right? Now, that's going to mess up my oxygens, but I have other oxygens over here. So I think that'll work out later. What I only have 1 of is an H2O2, right? And I need 2 of them in my goal equation. So in equation 1, I know I need to double everything, right? So double everything. I put a 2 here, I put a 2 here, and a 2 there. I put a coefficient of 2 in front of the whole thing. And what does that do to my 188? Double it. So 188 is what? 360, 376? Is that right? 376?
I think you're correct.
Okay, so now I doubled it. This is matching up. So I think we're done with number 1. Now I'm going to go to number 2. What do I have on number 2? This matches up, right? And I don't have hydrogens, and I do have an oxygen over here. But watch how this works. So because my H2O matches up, it's on the right side, and it has the right number, coefficient in front of it, I think this is going to be good. So watch what happens when I actually, like this is a math equation, when I actually add these 2 chemical reactions together, what happens? Well, what I'm going to see first, my hydrogen on this side, this hydrogen, is going to cancel out with this other one. You treat this kind of like an equal sign, the arrow. And so these are opposing each other. They're going to cancel each other out. So this hydrogen cancels out, that hydrogen cancels out. This oxygen, I only have 1 of these, where I have 2 of these on the other side. So it's only going to cancel out 1 of these. It's not going to cancel out the whole thing because they're not even. So what I'm actually going to have happen is this 2 gets canceled out, and this O2 gets canceled out. And now, what do I have left when I add these together? I'm not including the top equation. So I have 2 H2O2, and my oxygen here has been canceled out, my hydrogens have been canceled out, so I have my arrow, and then I have what left over? I have an O2 and 2 H2O. So I have O2 plus 2 H2O. And so you can see, adding these 2 equations together, I now have that top equation. I wrote it backwards. I should have wrote the 2 H2O first. But I essentially have the same equation, 2 H2O plus O2. So now, what did I do? I flipped this from left to right, and I changed the sign, and I doubled it, which doubled my number, right? I didn't do anything to this second equation, so that number stays the same. And then I added them together, and it got me the formula that I want. So all I need to do now is add these 2 numbers together, and it's going to get me the answer that I want for this bottom formula. So 376 plus negative 572 is going to be like what, 296? Or no, 196. I think it's going to be like 196. If I did my head math correctly. 196. No. Negative 196. I might be doing this math completely wrong. I think y'all know negative numbers. When you're dealing with positive and negative numbers, you can mess it up pretty easily. But let's see if I was right. I have some confidence in my answer. So they're going to do the same thing. Check it out. First thing they're going to do, they're going to flip this equation. So they flip the top equation so everything's on the right side. The bottom equation doesn't need to be flipped. The next thing they're going to do, double that top equation, just like we did. They flipped it and then they doubled it. Then, when they add everything together, their goal equation is what they get out of the bottom. And when they add their two answers together, they get the goal equation heat change at the bottom too, which is negative 196, which is what we figured it would be. I think, yeah, that's the only example they give you. So let me open up the assignment, and you can kind of take a look at it. And if we need to, we can do some problems on the board. Go ahead and pull up sapling, like I am. Give me just a second, I'll open it up. Hess's law. I'm just going to open it up through tomorrow. Okay. It is open. And let's go ahead and take a look at it. See what we got. 6 questions, so not the longest assignment. Note that the assignment from yesterday is still open. If you didn't get done with it, it'll be open through tomorrow. So here you go. Question number 1. Remember, there's only 2 things you can do with these. You can either flip it and change the sign, or you can double it and double your answer. So if I have A to B and it's 60 kilojoules, what do I need to do if I'm going 2A to 2B? Double it. And 60 doubled is a specific number. That's going to be your answer. Same thing. A to B is 60. Well, what's B to A? If I flip it left to right, what do I do to the sign? Change the sign. So instead of 60, it should be negative 60. So you kind of see what they're getting you to do here. If I want to go from A to B, it's 60. If I want to go to B to C, it's negative 130. What's A to C? All I got to do is add A and B and C together. Gets me all the way from A all the way to C. And so let's see. Let me go through these and see if there's anything really hard. On which one?
B to A.
B to A? A to C. So look. So think of it as dollars. If it costs me $60 to go from A to B, but I get $130 back to go from B to C, then what I have to do to go all the way from A to C, I just need to add those together. All you have to do is add them together, and that will be your total. A to B plus B to C equals A to C.
How do you go B to A? When I go like B to A, you would
How-
just do negative 9.
Yeah, how would you go to B to A?
You would just negative it. Yep.
You're going backwards, yeah.
I doubled it.
And C is half and half.
It's not
That's
what's
doubling.
rounded up to 200. Oh my God. That's what it is. Look, who's getting their A to C wrong?
I'm getting my A to B.
If you get your A to C wrong, try rounding
It
it.
was the first one. Yeah.
Oh, yeah. On the first one.
No, it was the 2A.
Oh, it's the 2A to 2B. So if you're getting that one wrong, the 2A to 2B, really any of them, maybe try rounding. It's going to seem crazy, but like if you have to round from 160 up to 200, I think that's what they're asking for you to do. So like 2A to 2B, mine says 60. So if you double 60, it would be 120. If it's counting 120 wrong, you need to round that down to 100.
About 270.
Is it counting it wrong?
300.
Then it should be rounded up to 300.
Thank you guys.
Yeah.
This is B.
Huh? A to C. Look, if you go from A to B and it's 60 kilojoules, and then you start at B and go to C and it's negative 130, to go from A to C, you're just doing both of those. You're adding them together. You're summing them together. Look, there's two things you can. So look. You're either going to do one of these two things. If you flip it from left to right, you change the sign. And if you multiply the equation, you have to multiply the answer. Those are the only two things you can do to any of these equations or numbers. If it flips left to right, you change the sign. If it multiplies bigger, you multiply the answer bigger as well.
How do you know which one you need to do?
Okay, number 2. You're talking about number 2? Yeah. Number 2, what you have to do, and this is going to be a little difficult, you have to get these 3 equations to add together like we did over here and equal up to that bottom equation. That's what they want you to create as the bottom equation. So let's just take a look at it real quick. What you want to do is you want to see unique things that don't exist in other equations. So what I'm spotting right here is xy3. The first equation I see at xy3. There's not an xy3 in either one of the other 2 equations, right? So the only place I can get this xy3 for my bottom equation is up here in this one, right? So I know what I have to do now, because what's the difference between these 2?
Flip them.
They need to be flipped and then what?
Reverse.
Flipped and reversed. And you flip it to the left side from the right side, and then I need to do what to it? Because I only have 2 here.
Multiply.
I need to multiply by 2. So this whole equation, just by this one chemical, I know the only thing I can do to it is I have to flip it and change the sign, and I have to double it and get it up to 4xy3. So this equation, I don't have to do really anything else. I know that I double that number and change the sign. So instead of negative 380, it should be positive 760. Now that number's locked in. I can write that down. I don't have to do anything else with it because I know that's the only thing that can happen. So the next one, I have what? XZ2. I don't have an XZ2 anywhere else. So this is my sole chemical for this equation that I'm looking for. Down here, I have an XZ2. They're on the same side, but what's the difference between them?
Multiple by 2.
They need to be doubled. So you're going to double this number. You're going to leave it negative, but it has to be doubled. So the first one, we changed the sign to doubled it. The second one, we're only doubling it, but we're leaving the sign the same. And now the third one's the only thing I have to figure out. The X2 or the Y2Z is my unique chemical here. I only have one Y2Z down at the bottom. And what do I need to do to get those to be the same?
Multiply 6.
3. Yours might be different. If yours is different than mine and you need to do 6, do 6. But I'm going from 2 to 6, so I need to multiply by 3. That's going to get me up to 6 here. So I'm going to multiply this answer by 3. So that's all I need to do now. Flip this, multiply by 2, multiply the middle one by 2, multiply the bottom one by 3, take those and add them all together, and that should be your final answer.
What about number 5? You should say my A to B is
Hold on, let me come see. And then I'll look at number 5.
Oh, different numbers.
On which one? Round that up to 200. Yes, and then round that down to 200. Did I count it right? Yeah. The 210. It's all about the significant figures. I don't like when they do that, but they do. So what you doing to be the A? Yes. No, because that's 3A to 3B. The A to B is only 70, so it should be negative 70. Yeah. Okay, let's take a look at number 5.
When you multiply these 2, are they supposed to go positive? Both of them?
No, these 2 will still say negative. This one you flip the sign, and so it does become positive. But no, when you multiply them by 2 or 3, they should still say negative. Let's see, number 5. Okay, so number 5. Okay. No, we're good, we're good. So look. Number 5, yeah. Yeah, we got this. So look, for number 5, what you want to look at, your goal equation first. And the thing is, the goal equation only has 3 chemicals, right? And if you look at them closely, each one of these only belongs in one of these formulas. So you use those to know whether you flip or multiply. So like what I'm seeing is the Ca, that's a solid. There's only one Ca solid anywhere in here. It's right here. And so it's on the right side and it's the right number, right? So this middle equation, I don't do anything with. I leave it just the same. It's already locked in. The half and O2. We don't ever have a half as a coefficient, so that's wrong in the first place. But Sapling did it. We can't change it. So I see a half of O2 is gas right here, and there's no more O2 anywhere else in here. So this one's okay. It's on the same side, and it's the same number. I leave the top 2 just like they are. Now the bottom one is just the CaO solid, right? Now I don't see that anywhere else over here. And so in order to get this on this side, I've got to do what to this equation? Flip it. So the only thing I change out of all 3 of these, if your problem's just like mine, is I change that bottom sign, add those 3 numbers together, and then I'm done. That should be my answer. What number? Number 2. Let's take a look. All right. So look, on number 2, what you want to do, let me show you. Let's see if I can.
Did you say for the third thing, or for this, just to flip the sign?
Yes, yeah. If yours was like mine, yes. Let's see.
He's not going to impact there. You just let me yell at you. You said about this.
Calm yourself. Take
That's
chill
not
pill.
what you said.
Okay, so let's see.
Divided by 3.
6. Can I confuse them?
No, it's not. I got it.
Yeah. All right, and pin and red. Okay, good. Yeah, we're good. Okay. So look at that. For number 2, anybody that's still working on number 2, let me show you what I'm seeing. So what I see for each of these equations is one chemical that isn't in the other equations, but it's only in the goal equation. So for the top one, it's this 2xy3. So here, I have an xy3. There's not an xy3 chemical anywhere in any of the other equations. So I know in order to get 4xy3 on the left side, it's got to come from this equation, like it has to. So what I need to do, I need to move this to the other side, which means I'm going to flip the sign. So instead of negative 380, that becomes positive 380. And then what I need to do, instead of 2xy3, I need it to be 4xy3. So I got to double this whole equation. Everything in the equation needs to be doubled. So instead of positive 380, it goes to 760 because I doubled it. So for this equation, all I'm looking at, I'm not looking at anything else, only that 2xy3. I have to flip it and double it in order to get my goal equation to work out. So I'm going to switch to a different color and we'll look at the other ones. For the next one, I'm seeing this xz squared. The xz squared is only on the right side. That's the only other place I see this in the entire problem. So I know I'm on the right side. I don't need to change the sign or flip it, but I need to double it because I need an extra 2 xz2s. So if I double it, that's going to convert, and it's going to double my number to negative 360, which I guess is not the right color I should have used. Let me just go back and use this color. Yellow's not the best color. Let's use blue. That'll work. Got the 2xz2 and the 4xz2. And so I know I have to double it. And that comes out to negative 380. No, 360. And then the last one, what I'm seeing is this. Let me change colors again. I'm seeing this X2 or no Y2Z. Y2Z. There's only one other place the Y2Z exists, and so I know it's on the same side. It's on the right side, but I need to triple it. And so this is going to be tripled to what? 6, 8, 16, 24, 840, negative 840. Which again is not a great color to write that in. And then all I have to do to solve this, now that I've altered all of my heat numbers, I just need to add them all together. So 760 plus negative 360 plus negative 840 should be my answer. And yours if you have this exact same problem. If yours is a little different, I don't even know for problems like this if they do different problems. I would try it like it is first, and if it counts it wrong, then maybe round. Nice. Good job. Good job.
What the?
Let's see.
I did wrong again. Dude, what?
Yep, number 6 is going to be a little bit more of the same. Number 3, they give you some multiple choice answers, so that might help out a little bit.
Can you go back on that page where that's on?
Yeah, here.
Thank you.
Yeah. Right, so for those of y'all at home, if you have questions or need help, which is likely, you might need help, send me an email and I will get back to you and help you out. Thank you.